Hello guys and welcome to my YouTube channel. In this video I'm gonna show you how to make a digital lock using Raspberry Pi and Python. For reading ADC I'm gonna use Raspberry Pi Pico. Here's the connection. ADC channel 0 is connected to GPIO 26. ADC channel 1 is connected to GPIO 27 and the last one is connected to GPIO 28, which is ADC channel 2. Now let's program the Raspberry Pi Pico in order to read the data from potentiometers and send it over UART to another Raspberry Pi. Okay, here is the Python code. From machine we are going to import pin and UART. Import time, and here's the definition of number of samples which we are gonna make from the ADCs in order to make the data very smooth. We will read ADCs from 3 channels and assign it to a variable. Then we are gonna initialize UART, which in my case I use UART 0 with baud rate of 9600. TX pin is assigned to 0 and the RX pin is assigned to 1. The ADC return value is 16 bits. But as I'm gonna use just 10 bits, I shift 6 bits to right. Here I'm gonna read it 10,000 times and assign it to the value in order to make the average. Here is the final value, which is the division of main value by number of readings. Now it's time to send it over UART. Here's the format. I set as 4 digits. From the other Raspberry Pi, I'm gonna separate the data by commas, so I put here commas. So I made it 0 leading in order to make the real value as 4 digits. After making this string, I'm gonna send it over UART by the command UART write. And from this command, I'm gonna see the real values here in shell. And here's the small delay in order to send data every 10 milliseconds. Program the Raspberry Pi and see the results. Here's the value of 3 potentiometers. Now let me change them. The orange one is the middle one. The green one is right and below is left. The Raspberry Pi RX TX pins are these 2 pins. The 5th pin is receive. So when the Raspberry Pi transmits, this pin should receive, so I'm gonna put it here. Since it's a single way transmission, this pin is not necessary actually, but I'm gonna connect it. Here's the ground pin. We should make the grounds common, so I'm gonna put it in the grounds section. And in order to make a relay switch between on and off, I'm used a relay module here. Just add VCC to VCC, ground to ground, and input is connected to the 3rd pin from bottom of Raspberry Pi, which is GPIO 16. Here's the ground pin of module. For the Raspberry Pi, I use Tkinter library, which is a graphical library in Python. You can make buttons, text, or any other graphical components. Here I use the relay pin as GPIO 16, which I'm gonna make it on or off. Here's the password data, which is gonna compare to the data coming from Raspberry Pi. When the data from Raspberry Pi Pico, they're gonna compare to these values, and when all of them match this data, it's gonna make the relay on. Here's the circular canvas definition. You can set radius, width, or color. Here is the definition of progress bar. When the data comes from Raspberry Pi Pico, it's gonna update it here. Here's the initial part, which you can give the title, the total width and height of the main screen, circular progress, their color, and etc. These three are the button which you're gonna see in the bottom of the main window. Here's the definition of UART. When we press the button, they're gonna start reading the data. Matching of password. If all the three data match the main value, it turns on the relay. This function reads data from the serial port, decode them, and as you see here, it's split by commas because the data format coming from the Raspberry Pi separated by comma. Here's the matching condition. If the data coming from the potentiometers all match together, they will give access and make the relays on. Now let's run this code. As you see, when I press, nothing happens because all the three data should match the value. Now all the three values are now 1000 and I'm gonna press enter. You see that the LED goes green. Now when I change the value and press again, it's gonna turn it off. Thanks for watching this video, guys. Please don't forget to like, share and comment below. Also subscribe to my YouTube channel for more videos.